As we're building our understanding of what's happening to the signal as it travels from point A to point B, we've got a lot of things to consider, right? We know it's losing strength because of free path loss. We know that stuff in the way is going to absorb some of the energy of that signal. We know that certain surfaces cause reflection, but reflection can actually cause an interesting issue called multipath. Imagine that you have an access point that is generating a signal, as we see right here. And that signal we expect to simply travel between the source and the destination. And that's true, it does. But remember, signal is moving out in a waveform. It's not traveling inside of a wire between the destinations. So think about that wave emanating out from that access point. As it emanates out, certain angles of that wave are going to hit potentially some reflective surfaces. Maybe we've got a metallic ceiling, or maybe we've got this filing cabinet here that cause reflection. What do we say happens with reflection? You end up with the signal not continuing on its straight path, but instead bouncing off at an angle of reflection. Now, what that means is that our antenna here might receive the same emanated signal 3 times. But let's think about this. Those angles of reflection are a little different for each of these things. And if you were to measure this distance, let's say the distance between point A and point B is, say, 10 meters. This angle here, we might have, maybe it's 6 and 6. That's a total of 12 meters that it takes for that same signal to get from point A to point B. Maybe going this way, it ends up being 7 and 7. And so that's 14 meters to travel the same distance. Again, because of the angles that we're working at. What we end up seeing then is that because some of those signals took longer to get there, even though they're moving with the same amplitude, they're the same frequency, they are the same wavelength, they show up in that antenna at different times. And so the receiving antenna gets signal, and if we just take in that signal, what do you see there? What is the actual wavelength of that signal? What is the information being conveyed? Is it this, or is it this, or is it this? You see, I've got 3 pieces of competing information showing up at the same time because the same signal arrives at the antenna staggered because of the additional distance the angle of reflection caused before it was actually received. This, without some sort of controlling mechanism, creates chaos. It creates a destructive force against the signal. These delayed multiple copies of the same signal hit the receiver, and again, you move if I move this device here, move it closer, well, then that doesn't happen. Or even if I were to move that same device and I were to move it, let's say, up here, so it's through the ceiling, it's on the next floor above. Well, then again, there's going to be a straight line here. We're shooting straight through it, and again, maybe I'm able to actually get that signal without that same multipath issue occurring. The thing to remember about multipath is that it is based upon the phase of the signal, and it essentially just means where in the wave is it, because the position in the wave is determined by the distance from the source to the destination, because everything rides that certain particular wavelength. So therefore, if we're at the 14-meter mark, we're going to be different in terms of the information we're conveying than we would be at the 12-meter mark or at the 10-meter mark. If a signal is received by the receiver at a particular point in the wave, we see that right here. If there's a multipath signal that shows up, and let's say, for simplicity, we have something that shows up 1 hertz later. 1 hertz meaning that it was fully in phase. It's exactly 1 second later, it receives the same point, the same crest of the wavelength being received at that same point. It's in phase. That simply duplicates the signal that's already there. It's the same signal, it's just stronger. Ha-ha! However, we can end up with signal that muddies the water. And that's if it showed up just a little bit late. If it was 1.5 hertz late, well, then it could show up 90 degrees out of phase, is how we refer to it. Again, meaning if we look at that signal, here it's coming up and reaching the crest. Here it's already reached the crest and it's halfway, and it's working on being halfway down. Or we could receive something that is 180 degrees out of phase, which brings it all the way to the exact opposite of the signal. If this is +1, this is 0, this is -1 in terms of the phase relative to the main signal. Now, Being 90 degrees out of phase, it means that the signals are muddied. It's a little harder to understand. Being 180 degrees out of phase actually cancels the signal. This is what happens when you wear noise canceling headphones in order to, you're on an airplane, you don't want to hear all the noise around you. How is it doing that? Those noise canceling headphones listen for the incoming signal and then transmit 180-degree out of phase noise relative to that signal so that you hear nothing. It's amazing. They can pick that up, do the processing, and spit it out before your ear gets a chance to hear it. So from the outside of the headphone to the inside, it's generating that signal and sending it in. Well, again, that multipath problem that we just looked at generates something that might be, again, here's our main signal, and maybe this guy is 90 degrees out of phase. That means that the signal is not as clean. You're going to get more errors, could be an issue, kind of like static on the radio. Here it's 180 degrees out of phase, and suddenly we've got noise canceling headphones on our Wi-Fi, and I get no signal at all. So multipath, definitely something to watch out for. Interestingly enough, with the correct processing, such as we see in 802.11.AC, multipath is actually used for us rather than against us, using a multiple input, multiple output utilization to actually track these signals, use them for good, intentionally bring them in to manage the signal in order to use multi-user, multiple input, multiple output to track individual users based upon their signal orientation. Some crazy stuff can be done by measuring the distances and the delays between certain signals in order to kind of lock on to individual users working with an access point. But unless something is put in place, and I was working in the 802.11g network, for example, this is a serious problem.